All right, so hey, very short introduction. My name is Veerle van Leemput and I am an R and Shiny consultant and course instructor. And in these 10 minutes, I'm going to give you a little, very quick crash course on automated testing with GitHub Actions. So let's first start with the question, why testing? Well, probably you know that testing is very important, mainly because if you are testing things in your production environment, which you can see in this nice little image, it can be a bit messy. The production environment is a messy place, lots of stuff happening there, and you rather not want to, have a test drive there. So therefore, we often set up a testing environment to conduct our tests. So as you could see, production is a dangerous place. You don't want to test your code right there and then. Furthermore, it ensures code quality, it reduces bugs, eventually saves you time, and increases your confidence in code changes, which is a nice feeling if you can just make a change and then push your things to production. So how would you normally do this? Well, normally for a majority of people, you would have an R package, for example, and you would typically, if you got to that stage, write some tests, then run these tests kind of manually using either dev tools or test that or whatever, then fix your bugs and repeat the process. And then if you're happy, push your changes. But the reality is, that second step, actually running the tests, is often forgotten. You don't feel like it, you're in a rush, whatever. So you end up not doing it. And a similar thing could be said for a Shiny application. If you have a Shiny application, you would normally, launch the application, click around, do some manual testing, see if nothing breaks, and if everything works. If you find something, fix the bugs, and then repeat and push the changes. Now, what happens here in this scenario as well is that you are getting sloppy with your manual testing. Eventually, it's just going to be running the app, click one thing, maybe two things, but the whole list of things that you actually need to check, you're not going to do that because it's becoming a repetitive task. So we don't want to do that. We want to work smarter and definitely not harder. And when we are writing tests, we want to enjoy them forever. And yes, you can enjoy your tests. So what do you need to actually achieve that? Well, first of all, you would need some kind of an R package to have all your functions and all your logic in. You can also have a Shiny app in an R package. Now you would need to test that package and use this package if you want to make your life a little bit easier. And you would need GitHub Actions to automate this testing process. Now, optionally, you can also have Shiny Test 2 for testing Shiny applications, which I will show very briefly. And optionally, you can have or make use of covr, which is a package that can calculate test coverage for you. So how would we do that? Let's take a look. Let's say we have an R package with a very simple and very sophisticated function, namely take break, that calculates or returns whether or not you should take a break. This take break function takes a couple of arguments, namely what's the weather outside, what is the time you have been working already, and what's your workload. And based on that, we will come up with some logic very simply to just return true or false. You can inspect all this code yourself a little bit more at ease after this crash course. Now, similarly, we could also have a little Shiny app in our R package, for example, in the ins directory, where we would have a very simple UI where you can input all your arguments, and output would be a text output that simply outputs whether or not you want to take a break. Now, the point of this is that we want to have tests in place for both the function and for the Shiny app. Now, we would need to have tested to actually achieve that. We need to write our basic unit tests. And for that, we first of all need a teststat structure, a project structure. That means that we need to have a teststat directory and a teststat file and the belonging files. Or we could make our life easier and just call a use teststat from the use this package, which creates it all for you. And then you kind of end up in this project structure. So you have a test directory, then you have an R file called teststat.r, We have a folder, test that, and in that are individual tests for functions you would like to test or Shiny apps you would like to test. Now, this test file looks like this. A test file normally has some expectations. I'm not going to walk you through how exactly you need to write tests. The point is that we now have a file that we want to test or run automatically every time we make a change to the code, because, you know, we will forget to actually do that. So here we have some expectations about what our supposed outcome should be for the take break function. Now, similarly, we could have this for a Shiny application. In this case, we would make use of the Shiny test2 package, and we would have an additional test file called test Shiny, or whatever you would like it to be called. And that file looks the following. It's a simple process that launches the Shiny application, clicks through some inputs, then expects a certain result to end up on the screen. Again, we want to run this file automatically every time we make a change to the code. Now, additionally, I said we could make use of covr because we have written those tests and we would like to calculate whether or not these tests are actually covering our code base. And in an ideal world, we want to have 100% coverage. There are two nice functions from the covr package that we can use. We have package coverage and we have function coverage. And as the name suggests, one does the whole package, the other one does individual functions. But we would also like to automate this process so that every time that we add new code and we have not written a test, we would see our coverage drop. And every time we did write a new test for our existing code, that we would see the coverage go up. So it's a way for us to help improve our tests eventually. Now, this is the output of what it would look like if you have a perfect package like the demo package that I made. So we now have a couple of steps. We have these test files. They need to be, run every time. And we have also the package coverage that we want to check. And we need to do this every time. That's not handy. So hello, GitHub Actions, and we can automate this process. So what is GitHub Actions? It's basically a way of setting up automated workflows that get triggered whenever you push a change to your repository on whatever branch you specify. In most of the cases, this will be the main branch. So that's super handy. Now, to run actions, you would need a couple of things. First of all, is a GitHub folder. In that is a workflows directory, and in here you will have certain YAML files that define the steps in this workflow. Now, you can have one big workflow file that does multiple things, or you can have multiple smaller workflow files, which is the thing that I recommend. Now, in this case, we would have two workflow files, one that does the RCMD check that also runs the tests that we have written with test.dat, and another one for calculating the test coverage. Now, luckily, we don't have to come up with these files ourselves. We can use the use.this package for that, which has these GitHub action files in there, where you can simply run this code and then the YAML files will end up for you. So let's take a very quick look at what those files are looking like. This is automatically generated, so no need to worry about it. Basically, this specifies all the steps that need to be taken for this job to actually run on multiple operating systems in kind of multiple environments with different R versions, for example. You can expect the code later in the GitHub repo. Now, similarly, this is one for RCMD check. This is the one for test coverage. Looks very similar. We have a couple of steps that need to be taken to actually run the code that does the package coverage, and that calculates it. Now, what then happens is that every time that we push a change, actions will automatically run, and it can be a pass or a fail. Now, what does that look like? A pass looks like a green check mark, and we're all happy. And as you can already see in the screenshot, sometimes it goes wrong as well, and you will get a red cross, and that means that your tests have failed or something is wrong or whatever. So this is a very convenient way to automatically test your package. If you want to show off your efforts, you can also use badges in your GitHub repo, and that will kind of look like this in my example repo. So the results of this are: you're not forgetting to run tests anymore. It automatically happens. If something fails, you will get an email, so you immediately get notified. And you can always show QA that your code is a percentage covered by tests. If you want to learn more, check out the slide and what everything is on there. Unfortunately, no time for questions in this 10-minute crash course. If you have any questions, just ask them, and I'll come back to you either on GitHub or on LinkedIn or Blue Sky or wherever you can find me. Thank you for joining and enjoy the rest